Buenos dias, Mr. Stone here. We're going to continue looking at this thing called the elimination method as a means of solving linear systems. To date, we've been doing that really just with addition and subtraction. We can throw in multiplication and division into the mix. We're going to do so right now. So let's take a look at this guy right here. 3x plus 5y equals 7 is the first equation. The second equation, x plus 2y equals 2. Looking at this, is there any way that I can add the two equations together that would cancel out any of the variables easily? And really, no. Even if I multiply everything here by, in the second equation by -1, I'm still not fully canceling everything out. But what I can do is multiply one of the equations, and if I do that, as long as I'm multiplying the entire equation on both sides, that's okay. Because as long as I do it to one side, I can do it, and I do it to the other, equality is preserved. So really what I'm going to do is take this whole thing, and if I want to eliminate the x, I can do that just to multiply it by -3, both sides. So quite technically, I would do something like this to multiply both sides by -3. Let's see how this works out. So after I've multiplied, I distribute the -3. The positive 2y that I had right there becomes -6y, and then the positive 2 now becomes -6. I can now add these together. I'm left with 0 when I combine 3x and -3x. 5y and -6y leave me with -y equals 7 and -6, 1. If -y equals 1, then it follows multiply both sides by -1 times -1, whoop, times -1, y equals -1. Now I've solved for one variable. I can go back and solve this just like I've solved everything else of similar fashion that I've worked on lately. 3x plus 5, I'm just bringing that guy down and plugging in for y is equal to 7. 3x, 5 times -1 makes that -5 equals 7. I want to get 3x by itself. How can I do that? Add 5. 3x is equal to 12. We want x by itself. Divide by 3, x equals 4. So we had y equals -1, x equals 4. Now, not only do we have x and y, but we've also got an ordered pair. Normally we write x, y like that, so we could really write our solution as 4, comma, go back to the y, which we said was -1, 4, -1. That's it. Suppose, though, that we have something like this. Now, it's not very easy for me to multiply one of these by something to get the other one. 2 times really any number is only going to give me something that is even. I can't get that 5. And similarly, I cannot multiply 3 or 4 by anything to get the other corresponding y value. So it is fair if I multiply both. That's okay, again, as long as I'm being consistent. Let's take a look. So if I have 5x plus 3y equals 1, I see that I want to get I choose to get the 5x and the 2x to cancel each other out. If I multiply everything on the top by 2. So both sides, the left and the right. That gives me 10x plus 6y equals 2. Again, equality is preserved because I multiplied both the left and the right sides of the equation. Similarly, on the bottom equation, I multiply everything by negative 5. That leaves me with negative 10x plus 20y equals negative 80. I distributed, and I did, again, the key thing is here, I'm multiplying both sides of the equation by the number, so I preserve equality. As long as I do that, both sides are equal. So now I've got my two new equations here, and it's awesome because the x's can cancel each other out. Combine, that is 0. 20y plus 6y gives me 26y, and 2 and 80 give me negative 78. So 26y is equal to negative 78. I can divide both of those by 26. I'm left with y equals negative 3. Go back up here. I like this equation a little bit better. 10x plus 6y equals 2. 10x plus 6y equals 2. Plug in for y, 10x plus 6 times negative 3 equals 2. This becomes 10x plus negative 18 equals 2. Add 18 to both sides. 10x equals 20. Divide both sides by 10. X equals 2. X equals 2, y equals negative 3. I can also just rewrite that as 2, comma, negative 3. That's it. Okay. A few things to remember. First, eliminate one variable first to solve for the other variable. That can be x or y. In this particular video, I've eliminated x just to make some very clear examples, but it's certainly fair to eliminate that y if that looks like that's going to be the shorter, more efficient route to take, or easier route to take. It really doesn't make a difference. Your solutions should only be one set that will work in any case. You can multiply both sides of the equations if needed, or you can multiply both equations if needed. You always must multiply both sides. Your goal is to first eliminate one variable by adding its opposite from the second equation, just like we've been doing. Get one variable out and then plug in. So these two really are old news, just reminders. And here are kind of the new things. Yay, new. All right. Let me leave you with a little bit to think on. Please put this into your notes and think a little bit about this. Whoop, we're jumping around here. Whoa, come on. You try. 7x plus 4y equals 3. X plus 2y equals negative 15. Solve for x and y. All right, give that a go. Have a great day.